So a warm welcome to Adam Dew from Ireland. He's dialing in from Northern Ireland, and he is a robotics service engineer at Valk Welding in Ireland. Was previously a student at the European School. Over to you, Adam.
Brilliant. Hello, everybody. Ciao ragazzi. So, yeah, as Trevor was saying, I was at the European School from 2008 until about 2016 when I graduated. And then since then, I've moved to Ireland where I did my bachelor's in robotics, and then I've worked in Northern Ireland ever since then. So to give you a bit of an idea of my last 2 years of school, I studied physics and advanced math, as well as at the European School, there was a course running called microelectronics, which is basically electronics, circuit board design, and like low-level signals such as AND gates, OR gates, things that you might be familiar with in your coding, which I was able to use in the physical world to combine and play with signals, basically. So following that, I was thinking, I want to try and study something that relates my love for electronic engineering, mechanical engineering, and computer science. So in Ireland and the UK, we have this course that is called mechatronic engineering. And it is very simply a combination of electrical, mechanical, and computer science all mixed into a single course. So I was looking around for a year or two and I was trying to find a course that suited me. And I couldn't quite figure out what I was going to do. So instead, I am going to share. Brilliant. Okay. So when I finished European School, I wasn't sure where I was going to go. So instead, I decided to come to Ireland. I moved to a place called Cavan. Very lovely place in the center of Ireland. And there I went to a small college where I studied engineering technology. This is a simple course that gave me a nice basis in a nice variety of topics, such as maths, workshop theory, electronics, engineering workshop process. Very interesting then was also to see CAD both in 2 and 3D. So I was playing with software such as SolidWorks and Autodesk. But at the same time, I was also managing to practice electronic skills, and then also soft skills were exercised. We had a class that was very well done on communications. So things that equally are very important, such as proper letter writing etiquette, correct use of emails and how to communicate to customers and coworkers, which is unfortunately a skill that I find is quite overlooked nowadays. The amount of emails I get from people who've been in the industry for 30, 40 years, and they're asking me, oh, how do I attach this document to this email to send to you? So simple things that you would think, oh, absolutely simple, but still are missing from a lot of people. So I did this course for 1 year in Cavan, and then that was a precursor to me moving down south, and I moved then to Maynooth. Maynooth is a town just outside of Dublin, and this is where I moved and I did my Bachelor of Science in Robotics and Intelligent Devices. So what this is a course which was actually brand new when I started it. And it primarily focused on developing a knowledge of robotics and AI, which at the time was still relatively unheard of. But then obviously in the last few years has become very popular and it's been a bit of a buzzword. So luckily enough, I was kind of on the early edge of that. So topics that I would have covered then would have been basic maths, such as a bit of geometry, bit of advanced mathematics, some transforms, Laplace Fourier series, all things that would support a knowledge of electronic engineering and the like. Equally, languages, programming languages I would have studied there would have been things like Java in year 1 or 2, C and C++. An interesting language that we would use there in the engineering workspace is called MATLAB. It is a simulation and mathematical programming software, which is used for representing the real world through equations. It is a wonderful language, with the exception being that every array starts counting from the number 1. It is one of the very few languages in the world that does this, and you cannot tell how many times I was stuck for hours trying to figure out why an equation did not work, only to realize the indices were wrong. Yeah.
Interesting. Okay.
Correct. So following that, in years 2 and 3, I continued my robotics experience there, and then I was offered the opportunity to undertake a 6-month placement. If, as a side note, if you are ever given the opportunity to do a work placement as part of a degree, I would wholeheartedly say go and do it. The experience I gained trying to find a placement, as well as working in a placement for 6 months, was absolutely invaluable. So in this placement, I decided to go and work for a company called Yelo. Yelo are based in Carrickfergus in Northern Ireland. Give you an idea where that is. So there's Dublin. Maynooth was around here where I studied. I moved up here to Carrickfergus. So Yelo are a company that primarily develop test solutions for the photonics industry. Photonics is the study of light. So primarily they devise equipment for testing lasers. Be that lasers that could be used, in the old days would have been used more so for DVDs and CD players. Now the big push is for fiber optics and data transmission over long distances. So some of our customers there would have been creating lasers to send information over fiber under the ocean, over long distances. Equally, we had customers that were using devices that both communicated with satellites and were based on satellites to communicate back to Earth. So some really, really cutting edge high-tech stuff. And Yelo, what they did is they created test equipment for these lasers. So we developed test cabinets that you can see here now to get an idea of, that you would load a number of devices into. These are some laser diode devices. You would place them into the cabinet, and the idea is you would do what's called a burn-in. You would run the devices for an extended period of time and push them to their limits to see how they would fail, and make sure that if you put a device in a place that is hard to get, such as a satellite, you don't want it to die in 2 or 3 months. You want it to last 20, 30 years. So this is kind of what I was doing for them. When I was there, I worked some of my time on these laser testing, but I also worked a bit of time designing a separate system for them, which was called an OCR system. That is optical character recognition. Mm-hmm. So I built a system that can read text off of a device and interpret it. The same way as you can point your phone at text and the camera can read it, I designed a system that can read text, like very, very, very small written text on a laser device, and read its serial number. So that was one of my fun little side projects. So I designed, built, and commissioned that system for a lovely company over in the US. Which incidentally, I found out a year later, my partner's cousin is the CTO at. Completely random freak occurrence. Anyway.
Small world.
Very small world. Irish guy who moved over to Silicon Valley 20 years ago and then became CTO of a huge company. Anyway, I left Yelo about 7 months ago, and I moved to Valk Welding Ireland. Valk Welding is a robotic welding company that is originally based in the Netherlands, near Rotterdam. And they design and build robotic welding systems. So they take a robotic arm and they attach a welding torch to it, along with a whole bunch of cool accessories. And then they build the whole system around it so that any customer can come along and say, this is my product. I want it to be welded in this way. Make a solution for me, and we will. We do things that are as small as like 0.5 meter long, and we have systems that are 70 meters long. I have a system here in Northern Ireland that can take parts that are about 30 meters long in a single piece. Equally, we can take lorry bodies. So, to give you an idea, Valk was originally established in 1961. We now have 8 subsidiaries around Europe. So you see here, Netherlands, Belgium, France, Germany, Czechoslovakia, Poland, Denmark, Sweden, and of course our new site here in Ireland, which is where I am based. So as I was saying, we have certain customers here in Ireland. One of them is a company called BMI. BMI are a trailer manufacturer, and as part of their process, they need to weld a whole tipping trailer with about one every 24 hours. So they came to Valk and they said, we have a trailer that is about 16 meters long and about 4 meters wide. Can you make us a system that can weld this? We took a while, took a year, and we came back to them with a solution, and this is what it looks like.
Wow.
This is a suspended welding robot over a rotating lorry body. You can see there the arm hangs over the robot on a number of different gantries, and then the lorry body is able to be rotated around a central axis, and we can access all the different sides and weld it completely. So I'll let this video play and I'll talk a little bit as you see different parts.
So you're saying they needed that one every 24 hours. Did I understand that correctly?
That is correct. They have increased their production to the point they are putting out 1 lorry per day at this stage. Yep. So there you go. That is a slightly sped up movie, but you can see that is a 16-meter long lorry body that we entirely suspend between 2 points, and then our welding robot can weld both the inside and the outside.
So these are specific kind of lorries. They can't just go to a regular lorry manufacturer to get these done. Am I understanding that correctly?
That is correct. These lorries those ones are specifically made for the waste recycling industry. They have what's called a central door push, I believe, at the rear. Basically a door that pushes all the contents out from one end down to the other to eject all the waste. Yeah.
Now that you say that, it does look like one of those waste lorries, but it's very long. Like the ones that go around Varese would be much smaller because of the streets. Yeah.
Yep.
Interesting.
So, absolutely. So, and then another very cool customer that I have in at the moment is a company in the UK called Deep. Now, give you a brief idea, Deep's mission is to create underwater habitats, and they are doing this with additive 3D welding manufacturing. So think of your little 3D printer that you might have at school. They are using 6 robots in a circle to 3D print with metal an underwater habitat that people will go and live in underneath the ocean. So they can do both scientific research as well as just pleasure. Yeah. So this is a very cool company who are just starting to do their research, and we're very proud to be able to support them by giving them our robots and supporting them in their mission.
So what's the idea of the 6 arms, the 6 robots positioned in that way? Mm-hmm. What is the idea? Why?
Speed. Instead of having one single robot doing it, they have 6 robots to try and cut down the time. They are welding, a robot welding can move about 0.5 meter per minute, and they are trying to weld about 4 or 5 meters across in diameter and about 100 millimeters thick. So when you think that a welded bead is only 10 millimeters thick, that's 10 times around for every layer you want to go up. So if you can have 6 robots doing this, it means it goes a whole lot faster. At the moment, they're still on initial design, but this is what they're eventually going to be building. So basically, think of like a camper van underneath the water, but a very, very nice camper van.
Incredible.
Yeah. And all of this will be made with our robots.
And the purpose of these habitats are research primarily, or could it be
Correct.
used for pleasure? Could it be used to take a vacation?
It absolutely could. Let's see now. This is a bit of their history. In the 60s and 70s, they've had small different vessels they've been able to make, usually out of folded and rolled sheet steel. But now the idea is with the Vanguard and the Sentinel, they're going to be able to make much more complicated and larger shapes that are able to be tested to a much higher and safer level, especially given the unfortunate accident that happened a few years ago there.
Yes.
So obviously safety is at the forefront of everyone's minds. This is why everything is taking such a long time and they're being very careful.
Yes. Yep. I've heard about 3D printing for outer space, obviously, because payloads been what they are. To be able to go as far as Mars, it'd be much easier to be able to print stuff when you get there. Could that process be used for outer space, or are the equipment is too heavy?
The equipment tends to be quite heavy. The advantage of plastic, plastic 3D printing is obviously a spool of plastic is that size and it weighs 2 kilos. To give you an idea, that is a spool of our wire.
Wow.
It is about 1 meter tall, half meter wide, and it weighs 250 kilos, right? So carrying 2 or 3 of those for the possibility that you might need something is a bit too far gone.
Understood.
Yep. So maybe when we're much more advanced and we're living on Mars for a longer period, yeah, I could definitely see it as a possibility. So I have a little demonstration I want to maybe show to you guys here now. This is one of our welding robots that I'm going to show you now. Okay. And on it, I have a little demonstration tank. So I'm now going to just reset this, and you're going to have an idea of the speed that we run at. So you're going to see the arm slowly moving there. So at the moment, it's doing what's called touch sensing, where it touches the part all over so that it can check where the part is in the real world. Because the issue here is, if someone puts this part together and it's not exactly where it expects it to be, and it goes to try and weld, it could end up welding in the wrong position. So what the robot does is it touches the wire against all the places it thinks the weld is going to be, and then it does its actual welding. So unfortunately, now it's hidden itself a bit behind the back, but in a minute it'll come around and you'll be able to see a bit more. But what I'd like to, it's pretty cool. What I'd like to draw your attention to, if you can see it, is how fast this robot is able to move. So because of that, a key factor that we have to consider is the safety. So this is not what is called a cobot, a collaborative robot. A cobot is a robot that you can stand right next to and touch and not be afraid of. If it hits you, it's going to hurt you.
Okay.
This is not one of those robots. If this robot hits you, it's going to hurt.
Ouch. Yeah, can imagine.
Yeah. Correct.
We visited the Tesla factory in Fremont, California during the summer, Adam. And
Brilliant.
yeah, it was amazing. We saw the robots on the assembly line, and they had, of course, robots, and then they robots, which were the ones that hung upside down.
Absolutely. So in a second, this will turn back around and you'll be able to see a bit more of what it's doing. But as I was saying, because safety is such a key feature in so many of these products, we regularly implement what's called a light guard. This is an invisible light barrier over the front of the robot. which you might be able to just about see there. That yellow barrier there has one on each side of the system. And if I were to break this barrier, then try to walk into the system now, I'm going to just stick my hand in and you will immediately see the robot stop.
Okay, good.
Yeah, exactly. So
Send-
safety is always paramount.
Sure.
So now, just to keep it going, I'm going to reset.
That's it. So
And the
do you
robot-
use imitation learning, or are these programs to do these particular movements?
So there are 3 ways you can program a robot. The first is a very manual way. You take what's called a teach pendant, this, which controls the robot, and you stand there for a few weeks and you move the robot to every single point that you would like it to weld at. And then you tell it exactly where it has to move, and then you test it, and then you find out, oh, damn, it's doing the wrong thing. I'm going to be here for another 2 weeks. That was the old way of doing it.
Okay, interesting.
Now, Panasonic and Valk have a very cool software, which means even with the robot running in a different room, you can be using like 3D CAD almost, and you can be preparing the welding ahead of time on a computer screen separately. And it's a lot faster than doing it by hand in front of the robot.
So what kind of software are you using for that?
So we have, Panasonic have got a dedicated software for this, which is designed around their robots. And frankly, it is one of the better softwares, I'm very happy to say. Some other competitors have got their own version of it, which I'm happy to say doesn't work quite as well.
And so
yep.
you write code, you're actually writing code to program it, or you?
We are indeed, yep. Yeah. So we can write, the primary basis of our robot is going to be, what humans can understand is going to be Cartesian positions around the robot. The robot interprets those as what is called joint angles. So the angle of every position of the robot, every joint, can be bent in specific ways to make the end touch a particular position. So the robot saves those, and it tells it to go from point A to point B. It might start off like this and might end up like that. And it saves those, and then it creates this path. And that is what you are teaching the robot effectively.
So it's pretty agile. I mean, how much would a piece of equipment like that cost, Adam?
This system here in front of me actually has a lot of options on it. So it's worth about 300,000 euro, I think.
Wow.
Yes, absolutely.
Interesting.
We have systems that are significantly bigger and longer, and they can be pushing $1 million, $1.5 million per system. Yep, give you an idea. Yep.
Okay, good to know, good to know.
Yes. And then the new way we have of programming is a new software we've recently developed, which we're very proud about. And what that does is you basically load in the part into your software. You tell it exactly where you want it to weld. You basically just point it at the weld and you click go. So instead of you sitting there so you remember we've gone from months of manually programming on the teach pendant to weeks of manually programming on the computer, to now using one program that does it all in an afternoon.
So it's using AI?
It is using more of a reinforcement model machine learning.
Okay,
yeah.
Machine learning.
So we have taught it what a good weld position looks like and what a bad weld position looks like. And then it interprets that into, okay, I have this part here, my robot is here. How can I make these two move together to meet and achieve the good weld position?
Understand. Do you have much competition in this market?
There are competitors, obviously. Very happy to say that Valk is one of the premier welding robotic companies in Europe, at least.
Yes.
This is primarily due to the fact that we have a very, very close relationship with Panasonic, who developed these robots for us. and it's to the point that now we are one of their primary purchasers. So we buy about 200, 230 robots from Panasonic every year. And that means we're doing about 200 robotic installations around Europe every year. And because of that, Panasonic listen very closely to us. If we make a suggestion to them, they will usually turn around and say, that's a very good idea. We will implement that now.
Makes sense. Makes sense. So, I'm guessing you're really enjoying your job. What would you say is the part of your job that you enjoy the most?
So, part of my job that I enjoy the most, I'm a very hands-on person. So the benefit to me of working here at Valk as a service engineer is I'm hands-on every day with different robots. So right now I'm just here in our factory in Lurgan, but this morning I was actually at BMI, the video I showed you of the long trailers that we're welding. I was at their system fixing it this morning. Every other week I'm down around the country. Tomorrow I'm going down to near Nace to see another system that actually I installed last week. So it's a very active job. I'm always moving and I'm always hands-on with equipment and things that I love. So that is a big, big plus for me in this role.
Excellent. Yeah. Well done. That's great. I see your questions come in from Lorenzo. Go ahead, Lorenzo.
Hi. So basically what you do is like you buy robots from Panasonic and then you like build the welding part, or do you implement like other parts too?
Yeah, so we buy a robot from Panasonic that is just a bare robot. It has nothing fitted to it. They developed the robot with welding in mind. So all the cables and things are all enclosed so that any sparks that land on them are not going to damage anything. But apart from that, it's a bare robot that we get from them. And then we add on the torch and all the extras that you see that are all hanging on top of the robot. These are all the things that are needed in order to make it a proper welding robot. So we add all that. And then we also add all the safety parts, all the external axes that move the parts around and allow the robot to move up and down the frame. We add all of those.
Excellent. Thank you for that.
Thanks.
Good question, Lorenzo. Sylvia, you have a question? Please go ahead.
Yeah, so basically the arm, does it have a sort of memory? So like if it's working on something and then you shut it, like you stop it, and you restart it like some hours later, does it need to resense the object it's working on, or can it just continue?
That's a very good question. So do you remember at the beginning I was talking to you about touch sense, where the robot torch comes along and touches the part in different positions to see exactly where it is in the real world? So we normally do that at the very start of the program. And the idea is if we think the part is here, the part is actually here, we do our touching at the very beginning to know that it is actually here. And then that's where we effectively move the part in the program to that new position. That position is saved for as long as the program is open. So if I exit out of the program now and I was to restart in the middle of the program where it's not going to do that touch sensing, it will crash. Or if the power is shut off, you're going to have to go to the start of the program again. That's why it's useful, same thing in your programming, to not write a series of code that is so long that it's impossible to find your way through, to break it up into small chunks. And that's why we do a chunk of touch sense, a bit of welding, a bit more touch sense, a bit of welding. That way, if it gets interrupted halfway through a sequence, all you have to do is jump back to the last part.
Oh, that's very interesting. Gotcha.
Yep.
Good questions.
You're welcome.
Go ahead, Chris.
Yeah, I have a question. In the beginning, when you said that at the European school you did like this robotics course, when you went to university, did you feel like it gave you like a head start, a preparation, or did you still have to like catch up?
No, so you'll be very happy to hear that if you're doing, I assume you're in the European school?
Yeah, I am. But they kind of changed a lot of things. There's no more robotics.
So I didn't study robotics. I studied a course called microelectronics. It was run by Mr. Daly. So I'm not sure. I assume you're in the Italian section?
I'm English.
You're English? Okay, brilliant. Well, in that case, then, if they're still running the course, the microelectronics course, it is a good course to try and do. It is a nice basis in electronics and circuits. It gives you a good grasp of don't connect the wrong wires together because it will go boom. Give you that idea. Yeah. But it's more of a fundamentals course. On top of that, I studied Math 5 and physics. And then when I came to university, I found out that what I had been studying in 7th year was the same topics that I would study in 1st year university.
Right.
So the European School really gives you a very good head start. So if you're following the curriculum in 6th and 7th year, you're doing very, very well, and you will understand university level physics and math very well.
And then, of course, combined with the coding class after school.
Correct. Exactly. So I did a little bit of coding ahead of time, just in my own. Unfortunately, I never had a chance to do any Derville's classes, but my sister did, and she said she really enjoyed it. But because of that, I was able to pick up the coding quite quickly in my 1st year. And then in my 3rd and 4th year, I actually demonstrated and taught Java programming on the side as a demonstrator in one of the classes. So all this that you're doing at the moment with Derville and getting all the basics, as long as you understand the function of coding and how you can group it and sequences of code work, it's very easy to translate that into different coding languages. Yeah.
So long as you got the programming fundamentals, they can be transported.
Yeah, exactly. Yeah.
Well done. Excellent. I'm conscious that we've gone way over the allotted time that you.
That's absolutely fine. Yep.
Appreciate it so much, Adam. We'll just see if there are any further questions. Any further questions from the team? It's been so useful, so interesting. Maybe just close with maybe any advice you'd like to give to this aspiring group of coders.
Sure. Let's see. I was not a big fan of school in 6th and 7th year. I will always be upfront about that. And I was always thinking, right, I just need to get good enough marks and that I need to get out and do a degree that I really love. And to an extent, I still stand by that. But at the same time, I now recognize how important it is to understand the basics. So all these times you're thinking you're in math class and you're seeing, oh, I'm doing the same thing for the 10th time, I'm sick of this. The reason you're doing it 10 times is so that you understand it. And then the next time you see it out in the real world, you will see it and you will immediately go, I remember that from my class in 5th year, whatever. So take your time at the moment and learn the basics. And then you can add on so much more. But if you don't understand the basics at the moment, trying to build upon that knowledge becomes a lot harder. If you go into university and try to learn something from the very beginning, it's going to take you more time.
Thank you. I wanted to ask you, well, I want to be a developer, but here in Italy we have, I think, only 2 types of school, high school where I can go, which is, I don't know, Istituto Tecnico,
Scientifico e Tecnico. Yeah.
Yes. So where should I go if then I will go to also university?
Good question. So this was a question that Matt was asking us earlier, because some of the students on this call are doing the technical school, the one in Gazzada, and then there are other students who do the Liceo Scientifico Applicate. And the question was, does the technical school prepare you enough for university? Should you do a Liceo? Well, what's your thoughts on that?
So because like many of my professors say, many of my professors say that I should do Scientifico. but I don't know.
I can't really speak for the Italian education system because even though I lived in Italy, I went to European school. But like I was saying, when I left European school, instead of going to university immediately, I did what is called a level 5 degree, which is a before university level. It's a 1-year degree, and this is the course I did in Cavan, and it was like an introduction to engineering. So I know that there are plenty of countries that do these like low-level engineering or introduction to different courses, and that can give you a good idea of if you're interested in the topic. You might think, oh, computers is so much fun, but then when you're sitting there all day, you're kind of thinking, well, it's actually not that fun. And if you're stuck in a university degree, you can feel a bit trapped. So that's why I like the idea of doing a 1 year. It was easy to say, okay, 1 year. If I don't like it, I can last for 1 year and then I can try something else. But 1 year, you can always manage that. So that was a big plus.
Thank you.
It's like a bridge. It sounds like it's a bridge between secondary level school to before you go to university.
That's exactly what it is. Yes.
Yeah, I will share that link with you, Max, later with the rest of the class, so we can have an understanding of what that course was that Adam. Adam, I'm just going to ask. The experts are saying that all future careers will require knowledge of AI tools, generative AI specifically. What is your take on it? Are you using it in your day-to-day work?
So I will be completely honest. The only time I have used AI other than just messing around was last year. I did a degree in human resource management, and I had to write a very boring essay about hiring and firing people. So I said, this is really annoying. It's Christmas and the essay was due on the 2nd of January. And I was saying, I don't want to do this. So I did all the research. I did the work and I studied exactly what I had to do. I found all the information that I was meant to. And then I put it into ChatGPT and I said, write me an essay. And it was terrible. I mean, absolutely terrible. Every second sentence sounded nothing like me. So I don't know if it was worth the time that I put into it, because then I started doing one paragraph at a time and I was having it output things and I was going back and forth for hours. But in the end, I found a happy medium between ChatGPT's outputs and my real world text.
The combination.
Like a nice combination, yeah.
In your day-to-day work, you're not using Anthropic, you're not using Copilot.
No. Again, in my day-to-day work, if I happen to be more office-based and more, I'm not going to say more client-facing because I am very client-facing, but if I was more computer-based,
understood,
I probably would be, yeah.
Yes, okay.
But due to my day-to-day work, and until ChatGPT can pick up a screwdriver and fix the robot for me, yeah.
Good answer. Thank you again so much, Adam. Best of luck in your continued future career. Really appreciated you taking the time to speak to us this evening.
My pleasure.
Thank you so much from us all.
Absolutely. Best of luck, guys. Ciao ragazzi.
Have a great evening.
Bye.